0.4, push the point light to 0.7. And then now we have, by default, a very rough material that has no roughness. So let's go ahead and see what happens if I turn down the roughness. So you can see this is basically like when we were playing with the mesh Phong, you know, we're basically getting shininess. And this is basically doing the same thing. But instead of shininess in a PBR workflow, we actually go ahead and use this roughness parameter to change how glossy this is going to look from the outside. And you can see that it actually approximates it a lot better than, at least in my opinion, how it looked with the mesh Lambert material or with the mesh Phong. If I go ahead and change the metalness, there's no real better way to describe this aside from the fact that it looks more metallic. Like, I don't actually know, like, it's hard to describe the specific way that the light is bouncing off the object. But essentially, I mean, like, I have like a bike lock that looks like this, right? So it's basically just looking more metallic. And let's go ahead and turn up the actual light itself. Because the more metalness you have, the, I guess, it absorbs light less, and that's what makes it metal, but it also just bounces it off in a very specific way, but it also makes your objects look a lot darker. So these are the two properties that we can change with the mesh standard material. There also is something called a normal map that is going to be very important in PBR workflows, and again, we are going to approach that in the next lesson. And then the last thing that I'm going to show you is actually the mesh physical material. And the cool thing about the mesh physical material, the cool thing about, you know, understanding a little bit about the PBR workflow is it actually does everything that the mesh standard material can do. So it has the exact same workflow, mesh physical material. The cool thing about, you know, understanding a little bit about the PBR workflow is it actually does everything that the mesh standard material can do. So it has the exact same roughness and metalness workflow. So I can actually switch it out right here by doing mesh physical material. And you can see that these levers or these controls that we have work the exact same. However, there is a couple other properties that are going to be important. And specifically, they are, so pane, add input. Specifically, they are the clear coat and the reflectivity properties. So let's go ahead and try reflectivity. We'll set a min, we'll set a max, we'll set a step. And then you'll see, for one, if I actually go ahead and turn this to max metalness and I have low roughness and I actually change the reflectivity, you see nothing really happens. And that's because we have high metalness, we essentially just have the most reflective thing that we can get. However, if you have something with low metalness, prior to having this reflectivity parameter, there wasn't any way for you to get something a little bit more reflective. So now you can see that there is a difference. However, I would argue that you can probably approximate this reflectivity with some type of roughness and metalness combination. But again, at the lowest levels of metalness, you really don't have any way to get any type of reflectivity. And now you can do that with the actual reflectivity here. And then finally, we have something called clear coat. And what clear coat is, the easiest way to describe it, I may have spelled that wrong. Yep. The easiest way to describe it is basically like a wax. It's approximating the type of like clear coat finishes that you get on a car. And so I hope you can notice the difference between, yeah, you can see like it's almost like you put a like reflective gloss over it. And I think that Three.js actually does a good example of explaining it. So if you go to clear coat or depicting it, you can see that it's almost like you put this like layer of wax over it. And that's just one more parameter that you're going to be able to get with the actual mesh physical material. So those are all the materials in Three.js that I think are going to be important for us to cover. There are other materials that you can use, and I'm sure you can go ahead and go into the documentation and take a little bit of a deeper dive. I think you may have fun looking at some of the other materials that you may be able to use. But for us, I think this is more than enough to get started to building out a more robust scene. And in the next lesson, we will talk about textures, which will add a lot more context regarding the different things that we can do with our Three.js materials once we start feeding them textures. So I hope you're excited, and I'll see you in the next lesson. Properties of materials that will lesson. We talked about materials. We talked about the different general properties of materials that will impact the way that an object may or may not respond to light, how it may be rough, how it may be shiny, the different ways that we can essentially make the surface topology look different to the end user. And now in this lesson, we'll be talking about another part of materials called the texture. Now this texture is going to be provided to Three.js via some images. We're going to load it. I'll show you the different properties of textures. I'll show you how it maps onto different objects, as well as show you how we can use textures to provide Three.js with more information about some of those PBR properties that we talked about in the last lesson, which are the industry standard for conveying properties of an object as it relates to physical light simulation. So to get started, let's do a little bit of practice. Let's go back to I have my starter on my left-hand side, and then I have the actual practice a little bit of our Three.js by adding a couple more meshes, and we're going to go ahead and make them spin. And obviously this is just a little bit of setup so that we can see how our textures map onto different objects, but it'll just also give us a little bit of practice in actually setting up Three.js objects. So right now we have 3 objects lined up horizontally. So if I wanted to add other objects, we could add them above or below, just so we can take up an appropriate amount of our screen real estate so we don't create objects that are, outside the view of our camera. So another object that I want to add to the scene, because I think it'll be useful, I think there's lots of scenarios where you may be using this type of geometry, is actually a sphere. So let's go ahead and actually just initialize a sphere geometry. So we do that by doing const sphere geometry geometry equals new 3 dot sphere geometry. And then the arguments we're going to pass it is the radius of the sphere, and then the width and the height segments. And the more width segments you provide it, the more detailed it's going to be, but also the more triangles that it's going to use, the heavier it is to compute. So I think if we stick to 32, that'll be fine. And then finally, another geometry that may be also useful is maybe something like a cylinder geometry. And then we're going to do new 3 dot cylinder geometry. And then we're going to pass it arguments about the actual radius, so it doesn't. And then we're going to provide it the amount of radial segments as well. So this is similar to the actual sphere. Let's go ahead and save. And then what we're going to do is we're actually going to go to the actual sphere. Let's go ahead. Go ahead and save. And then what we're going to do is we're actually going to create these meshes, so actually take props, because I don't believe we've actually done that with our mesh. And it's just another way to actually meshes. So sphere and equals sphere geometry, and then you can assign the sphere material. Same thing for the actual cylinder geometry to the scene. So let's go ahead and actually each argument being a different thing that you want to add to the actual scene. So instead of calling these 3 times, instead of calling scene.add 3 times separately, what you can do, and this is up to personal preference, add them all into the arguments of one add method. So if I go ahead and remove this and I save, you see the first problem is we actually haven't seen any change or any difference in our scene. And that's actually because we have initialized both of those meshes still at 0, 0. So like with the other meshes themselves, we can actually go ahead and make it here, but instead we'll do negative 1.5. So let's go ahead and save. And now you can see we have our scene initialized. So what we learned here is that you could actually create a mesh empty with no arguments and then assign properties of that mesh being like geometry and material after the fact. And that's essentially what we've been doing with the actual position property. We're creating the actual mesh itself and then we're assigning the property after the fact. However, you may not have realized that this is also something that we can do with arguments of the actual mesh itself. The next thing we're going to do is we're going to make this a little bit more dynamic. So I want all of these different meshes to actually rotate. And one way to do it, if you wanted to brute force it, and because we've learned about this in our animation lesson, is if I just wanted to go ahead and do like sphere 0.01. Oh, actually, that's not going to be easy to detect, but let's do cube, because if a sphere rotates, you can't really tell the difference. But now if I rotate the cube, that's what that looks like. Another way, instead of having to, call it on the sphere and then the knot and the plane, another way to do it, let's say you had a lot of objects in the scene, is to actually access the scene.children property and then loop through all the meshes and then make them spin within the actual render loop. And so the scene actually has a children property, just like any other object in Three.js. So if we actually call console log scene.children, you should see that it's actually an array of different children that exist within the mesh. So if I go ahead and pull out the log and I go to the actual array, you can see that because it's an array, what you can do is you can actually loop through the array just like you would in any other JavaScript application. So to do so, we can do scene.children.forEach. So forEach is just a method array that is provided to us by JavaScript. There's nothing inherently Three.js about this. And that forEach is actually going to take a callback function, and then we can pass an argument of the callback function, and that argument is actually going to hold information about each child of that array or each object within that array. If I go ahead and actually log it out, just show you step by step what's happening. If I do console log children, and I'm actually going to pull this out of our render loop so we don't get it doesn't have to run through for each of the actual children within a scene. We went ahead and passed that children variable into the log. And so we have access to that children variable within our console. And you can see this is actually just the mesh itself. So this mesh specifically is the sphere. And so I'm sure you can imagine what we can do is we can actually just go to children.rotation.y plus equals 1, just like we did previously. Now, if I go ahead and save, I'll mention one immediate issue with this is that there are lots and lots of children of the scene, and some of them might not actually be meshes. So if we want our actual objects in the scene to rotate, what you may not want to do as a side effect is you don't also want to be rotating something like the lights, because if you had a directional light and that was rotating, that may not give you the effects that you actually desire. So in order to actually make sure that we're only rotating the meshes, we can do if child instance of, and instance of is but we can, on the screen, that's a mesh. Regardless of the geometry, we know that it's a mesh. So because we want to rotate all the meshes, if it is each, instead of children, I'm going to name it child. And then for this, because we don't actually, the lights in our scene don't actually impact material that we have, because we're actually starting, and you should see that there's no difference in our actual scene itself, because we don't actually, the lights in our scene don't actually impact material that we have, because we're actually starting off with a mesh basic material. So that's one way to actually rotate the meshes in your scene. It's a way that I have found to be fairly useful to actually loop through an array. Another issue with what we're doing right now is that there could be lots and lots of children within the scene. And so right now we have a fairly small application. There's only 7 children in the scene, but I'm sure you can imagine what happens inside the render loop happens 60 times a second. So if you have a really big scene and you really only want to rotate a few things, I wouldn't recommend looping through long arrays multiple times a second. So one thing you can do is we can actually initialize a group. And then I want to do const group equals new 3.group. And then what you can do is, instead of adding all of these different meshes to the scene itself, we can do group add, and then we can go ahead and actually add that group to the actual scene itself. Just like we did when we were working with the scene graph and while we were transforming properties. And then finally, if we go down here, we can actually do group.children, and that should work the same. So now we are making sure that we are only looping through everything that we add to the group, so we can be selective about the things that we add to the group, and so that we don't have to create large arrays that the render loop has to loop over. All right, so that was a decent amount of setup, but I hope it will actually just give you a little bit more practice into how to set up a Three.js scene. Now let's dive directly into textures. All right, now that we have our scene set up, let's go ahead and get ourselves set up with our first set of textures. Now, textures are any image. You can use any image for different textures, but to make it relevant for us, let's get textures that we may actually want to put onto materials that may be in a scene that we want to create in Three.js. And to do that, I'm actually going to point you towards a site called freepbr.com. And what they have is they basically just have a catalog of many different types of really cool materials that you can use. And then within each material itself, you can actually download a file that has all of the different textures that relate to the material as it relates to the actual appropriate PBR channels. We will dive a little bit deeper into that a little bit later on in the lesson, but for now, I'm just going to point you towards the site and I'm going to tell you to download the Wispy Grass Meadow, the Space Cruiser, as well as the Badlands, and there's going to be the examples that we use. I'll provide the links under the description, and I recommend you go and download those for yourself. And the reason why I haven't actually included that into the actual starter pack is because this is someone else's work, and this is someone that is actually providing it to you for free, but as well, you can choose whether or not to actually contribute. So I actually paid, I believe it was $9 to buy the commercial license or the commercial rights for this, because I'm making money off of teaching you with this material. And if you find this useful as well, I think $9 is a very, very reasonable price given 400 plus textures that you get, and you get it all into one file. So I didn't want to distribute someone else's work. So if you want to go and you just want to play with something for free, well, but as well, if you just want to, experiment with it and you just want to play with something, for free, they are 100% free to use as well. So So go ahead and download that, and let's go ahead and get ourselves set up. The first thing that we want to do is we actually want to initialize something called a texture loader. So in Three.js, there needs to be a way for you to import that texture and turn it into a texture that Three.js is able to recognize. And to do that, we're going to go ahead at the top of the scene and we're going to do initialize, or texture loader, because there may be other like model loaders that we will explore later in the lesson. And then we just do new 3.texture loader. So all we have to do is actually create this texture loader once, regardless of how many different types of textures that we have. Basically, this is just a utility class that has load methods on it, and we're going to call those load methods anytime we want to load the actual texture, and then we're going to pass the actual texture or the URL of the texture into the arguments of that load method. So let's go ahead, and after we initialize the material, I'm going to go ahead and actually initialize the texture. And to initialize the texture, we're going to create a variable to hold the texture itself. So we're going to call it texture test. And then we're going to make that equals to texture loader. Dot load, so that's the load method that I talked about, and then we're going to pass it a URL of the actual texture itself. Now that URL is actually just a path to the textures that we want to use, and I'll show you where I've stored the textures, at least within my repository, or at least within my working folder. If I go into the static folder, I have a textures folder. If I go into the textures folder, I actually just went ahead, extracted the texture, the downloads that we got, and I actually just threw them into the textures folder. The naming is the exact same. You can see if you have all of these different textures, then it means you've done it properly, and I just went ahead and actually threw those into the textures folder. So let's actually get the URL to that. And to do that, you can actually go into VS Code. And if I want to get access to this albedo texture, and this albedo texture is just another way of saying base color, I can go ahead and right click, copy relative path, and then I can paste it into this load method. I'm going to go ahead and actually remove this static, and that's because within our Vite config, Three.js or our application actually knows to look inside the static folder for any types of assets or any type of URLs we pass it. And so we can just start our actual URL from the textures folder. And then we're going to go ahead and do console. Okay, perfect. We texture test. So I'm going to log it to see if we have access to it. Okay, perfect. We have access to the actual texture itself. And then what we're going to do is we're going to actually change the map property being basically just a base color that we're going to provide it. And we're going to change that map property of the material. So let's go ahead and actually move this up before we initialize the material, because after we actually have the material itself, we want to go ahead and assign the map property of the material to the texture that we have. So let's go ahead and save, and you can see now we have our first texture applied to our objects. Because we actually initialized our scene with a mesh basic material for all of these meshes, at least with regards to the actual texture itself, what you see is what you get. So essentially, you know, the colors of this texture itself is actually mapped one-to-one to the actual mesh. Now that's going to be different with different materials. So for example, when we use a mesh standard material, this texture is going to define the base pattern underneath the material, but stuff like the actual lighting of the scene is also going to impact how it looks. But for now, because we've actually used a mesh basic material that doesn't respond to light or anything else, our actual image itself is going to map directly onto the output color of our material. Now, that's not to say that we can't actually alter this because, like I said, texture is actually just part of a material, and that is still true for the actual mesh basic material. So if I actually go ahead and do material.color equals new, you can see in that texture, you can still see kind of like the outlines of the grass. But now we've applied a very, very red hue to it. So this is just, once again, reinforcing that principle that texture is just one part of the material, but you can still go ahead and change other properties of that material. But now in this next lesson, I'm going to show you how to change properties of the texture itself, and I'll show you how that impacts the end material. All right, let's go ahead and explore some properties of the textures that we can change to impact the way that the material looks. As always, it's always good practice to actually explore the class itself within Three.js's documentation to take a look at some of the properties that may not be covered, at least in this lesson, or just perhaps if you're just trying to find out how to change something very specific in your head to see if that exists within the documentation, feel free to give that a look. But in this lesson, we're going to cover a couple of properties that will be relevant to many different types of use cases. So to get ourselves set up in this environment, I'm actually just going to be using the plane. So I'm actually going to comment the group.add out, and instead I'm just going to do group.add, and then we're just going to add the plane. And then as well, I don't want this to rotate anymore. So let's go ahead and comment out that part of the render loop. Finally, I'm going to rotate this as if it was basically like a ground. So I basically want a ground mesh that we're going to serve as the terrain. So to do that, I'm going to go to the plane. I'm going to rotate it on the x-axis. And I know that the x-axis is the one that we want to rotate because if I'm looking at this directly, I know that the x-axis is kind of the same x-axis that you see in graphs. And I know that if I kind of stick a skewer or a spit through this and I rotate it on that axis, what that'll do is it'll actually flatten it out. So we actually have a plane. So we'll do rotation.x equals math.pi, because I know that math.pi gives me a half rotation or a rotation of 180 degrees. If I want a 90 degrees rotation, I'll do 0.5. So now I'm rotating this 90 degrees. However, rotating this 90 degrees can rotate it one of two ways. It can rotate this clockwise or counterclockwise. I generally don't know which way it rotates by memory. It's the same thing. It's hard for me to sometimes know which axis to rotate by memory. So I kind of just like play with this. I know that this rotated it the wrong way. So if I rotate it the other way by wrapping this with a negative operator, I can actually rotate it upwards. And then I'm going to go ahead and scale this, scale dot set, and I'm going to set it to 100 by 100. And then I'm also going to raise the actual camera itself. So I'm going to set the camera dot position dot y equals 5. And then I'm actually going to increase the far property of this so we can basically see all of the mesh in its entirety. Okay, so I'm sure you can imagine an issue that arises if I actually set an absurdly high value for this mesh. And I'm saying absurdly high value for the scale, but in reality, it's very reasonable for you to have a very large plane or a very large mesh for the terrain itself. And what's essentially happening is we're basically stretching the detail of this texture. So this texture is actually very detailed, but there's a limit, right? If I keep zooming into this, if you could imagine, if I actually had this scaled up to like 10,000, eventually players are going to be able to see the ground in a very, very pixelated manner. So to actually solve this problem, Three.js has a repeat property on its textures, and this repeat property is a vector 2. So just like we have a vector 3, which has x, y, and z coordinates, a vector 2 has x and y coordinates. And we can use very similar operators that we use with the actual vector 3. So we can actually just access the x and the y properties of repeat directly, or we can set the x and y properties of a repeat by using the set method provided to us by the vector 2 class. So we can see that there actually is a set method. So you can do set, and you can pass it an x and y. And so that's exactly what we're going to do. And we're going to basically go to the actual texture itself. We're going to name it grass texture instead of texture test. Make sure that you reassign the material.map to this new name that we've provided it. And then we're going to do grass texture dot repeat dot set, and then we're We're going to provide it like 100 by 100. And what we're essentially doing is we're going to say, okay, let's repeat this texture 100 times on the x-axis and 100 times on the y-axis. Let's go ahead and save that. See what we get. Okay, so something's happening. It's, just one big green chunk. But if I go into the actual one of these corners, I'm actually going to go ahead and expand out the viewing distance. So I'm going to set this to maybe just 10,000 so we don't see we have any problems with any of our edges. If I go into this teeny tiny little corner, you can see that we actually have the original mesh, and then everything else is just kind of stretched to infinity. So what's basically happening is we can actually look and see that the edges of this texture itself is actually stretched to infinity. So what's happening is that we are repeating this like 100 times, and maybe 100 times was a little bit aggressive. Let's repeat it 10 times. And so we'll get a larger texture in the corner. So you can see we are repeating this kind of 10 times, and at least this texture is 1/10 of the size that it was when we originally had it. However, what we're doing is we're actually just repeating the edges of this mesh. What we want to do is we want to repeat this texture in its entirety and kind of like stamp it across. And the way that we do that is actually there's a wrap S and a wrap T property to all of our textures. And the wrap S property is with regards to the actual X axis, and the wrap T property is with regards to the actual Y axis. So let's go ahead and set these individually and see what grass texture. IS double socket integer. So we're telling, instead of just stretching the last pixel, we're going to repeat the entire image. So let's go ahead and save it. So now you can see that we've actually started to repeat or tile that texture along the x-axis so that when it gets to the end of the texture, it just repeats that texture in its entirety. We're going to go ahead and do the same thing for the y-axis, and we do that by accessing the wrap T property. And then now if we actually zoom out, you'll see that it's not just one big texture, but the same texture repeated 10 times on the x-axis and 10 times on the y-axis. If I wanted to make it even more detailed, I can obviously set this to a higher value. But an issue that you may see or that may occur is actually you can see now that there is, at least to me, a fairly recognizable pattern. So it seems fairly uniform, and for some it may look unnatural. So if you've ever played Minecraft, you may recognize that. It's a hard problem to solve. I mean, there's a few ways to solve this, not using some complex math, but you could just kind of expand the size of your texture so you don't have to repeat it that much, but that comes at the cost of having to load really large textures into your scene, which often isn't a best solution. So there's really not any easy way to fix this. But there are also other different types of actual wrapping that we can provide it. So instead of repeat wrapping, there's something also called mirrored repeat wrapping. And then it's going to be difficult to see how this looks with the grass texture. So let's actually just go ahead and load another texture for us. So maybe if we actually be this relative path, and then you don't have to follow along, I'll just show you. So I'll go see now, and maybe the best way to illustrate this is to actually do something like 2. You can see if we were to do regular wrapping, so I'm going to comment this out, and we're going to do, and I'm just going to do regular wrapping. This is scaled twice on the X and twice on the Y. And basically when we get to the end of the actual texture, what we actually do is we start back at the leftmost part of the actual, and I'm talking about the x-axis. We started the leftmost part of the actual texture, and we basically repeat it from the beginning again. So we're going from 0 to 100, and then at the middle point, once we start to repeat again, we go back to 0, back to 100. If we were to do mirrored repeat wrapping, we essentially go from 0 to 100, but now we're not starting from this leftmost part of the texture. We're actually starting from the actual rightmost part, and then we're flipping it. So we go from 0 to 100 and 100 back to 0. So I hope you can see the distinction. It does end up providing like a little bit of a psychedelic type of look. But yeah, that's just one option for you to actually repeat wrap. And I believe if you actually go to the wrap S, you can see that there are also clamp to edge wrapping, which is the default. What happened when we actually saw, when we went all the way to the end, and then instead of actually repeating it all over again, we just stretch that last pixel all the way out. All right, so in this lesson, we're going to cover another property that I think is going to be relevant to you, and it's actually going to be the offset property. Now, what this offset property changes is actually the positioning of the texture within the mesh. So right now we have it positioned so that you start the another. All right, so in this lesson, we're going to cover another property that I think is going to be relevant to you, and it's actually going to be the offset property. Now, what this offset property changes is actually the positioning of the texture within the mesh. So right now we have it positioned so that you start from the left-hand side or the top left-hand side, and then you start to tile this texture. I'm going to go ahead and actually set this back to the regular repeat mapping. But regardless of how this repeats, there's no way for me to basically tell Three.js that I want maybe this part of the texture to be centered onto the material itself. And the way to do that is with an offset property, and that offset property lets you change the actual positioning of the texture within the material itself. So let's go ahead and set that up. I know it's still called grass texture, but this is going to be a short lesson, so we're going to keep it called grass texture even though we're working with Space Cruiser material. And I'm going to change the grass texture offset property, and that offset property is actually a vector2, just like the repeat, so I can actually access the x property of it directly, and I'm going to set it to 0.5, and we're going to visualize the difference. Now, you may not have remembered how this looked originally, so let's go ahead and actually add a GUI in situations like this where you want to visualize the impact of the thing that you're changing immediately. So I'm going to initialize this GUI in a slightly different way. Instead of creating an X and a Y separately, there's actually a way to feed both X and Y properties as different separate objects into the same menu option. And I'll show you, this is just one option for you to do. It may not be the most intuitive or the most helpful, but let's go ahead and do pane.add input, and we're going to provide it with the actual. We want to properties in the top level here, the minimum, and then we're going to provide it the minimum. Is actually a new GUI that I actually set it to 0.5, so I'm actually going to remove that and just start at 0, 0. But this new GUI, whether or not you like it, is a different story, but it does provide us with a cool, unique way to now specify what we want to change this offset to. So for example, now if I want this to be in the middle, perhaps I would provide an offset, or maybe we should do minimum of -1 for both of these. And now if I want this to be centered, I can go ahead and just play with this, and then now I can go ahead and actually copy these values into the actual offset property. So this is just a way for you to experiment and play with the actual offset of your texture in relation to where it sits on the material in real time. And that's just another property that I think would be very helpful to you. Now, in the next lesson, we are going to cover something called UV maps, and we're going to explain how that accounts for the different ways in which textures map on. on two objects.